Histogram equalization. Histogram equalization is one of the well-known methods for enhancing the contrast of given images, making the resulting image having a uniform distribution of gray levels. It flattens and stretches the dynamic range of the image histogram and results in overall contrast improvement. This is an example. After transformation, the frequency histogram is equally distributed, thus enhance the image. Adaptive histogram equalization. For images which contain local regions of low contrast bright or dark regions, global histogram equalization won't work effectively. Adaptive histogram equalization is an extension to traditional histogram equalization which can be used on such images for better result. It operates on small data regions rather than the entire image. The contrast of each region is enhanced so that the histogram of the output region matches the specified histogram. A variant of adaptive histogram equalization is called contrast limited adaptive histogram equalization or CLAHE. Cumulative distribution function. Cumulative distribution function shows the proportion of pixels that have an intensity less than or equal to a particular value. The given example shows how the cumulative distribution function works. The original image, its histogram before equalization, and its cumulative distribution function is shown. When transformation is applied, the frequency histogram is equally distributed, then the cumulative frequency will be very much equal to a straight line. Clahe. The main steps performed by Clahe are: calculate a grid size based on the maximum dimension of the image. The minimum grid size is 32 pixels square. If a window size is not specified, choose the grid size as the default window size. Identify grid points on the image. Starting from top left corner, each grid point is separated by grid size pixel. For each grid point, calculate the cumulative distribution function of the region around it, having area equal to window size and centered at the grid point. After calculating the mapping for each grid point, repeat steps 6 to 8 for each pixel in the input image. For each pixel, find the 4 closest neighboring grid points that surrounded the pixel. Using the intensity value of the pixel as an index, find its mapping at the 4 grid points based on their cumulative distribution functions. Last, interpolate among these values to get the mapping at the current pixel location. Map this intensity to the range min-max and put it in the output image.
Now let's see our Python code. First we import the necessary libraries. We select input image and set the number of tiles. We slice the input image into 16 tiles here. Next we loop through each tile and apply the histogram equalization equation. We find the histogram for each tile using np.histogram function. We calculate the cumulative distribution function and then normalize it. We use masked array in NP to exclude 0 while finding the minimum histogram value. We apply the histogram equalization equation and fill the masked value with 0. We map the new pixel values to the input pixel value and save the tile. We then join all the tiles together to get the output image. Now we will run the code. So the image on the left is the input and the one on the right side is the output.